David Bosschaert, Carsten Ziegeler, and I am Karl. We are all long-time Apache Sling and Apache Felix committers, members, founders in some cases. So you might know us from previous adaptTos and our work in open source and around AEM in general, and more recently also edge delivery services. And so today we want to talk about, well, actually, it has two aspects, right? So the one is we want to talk about our attempt to teach an old dog some new tricks. That's one. And the other side is that we have a couple of long-running, years in the making personal initiatives that we are driving with Slings that combine in this and hopefully open up a new use case for Sling. And really the story is that at last year's adaptTo, that's where it started. If you remember, Adobe had just announced edge delivery services. There was lots of talks about it, questions, excitements, doubts, all of the above, but it was on top of everybody's mind, at least, let me put it like this. And it just so happens that on Tuesdays, if you don't know, we always have the Sling committer roundtable at adaptTo in the evening, where we discuss various aspects around Sling and what we want to do. And one of the topics was that our static website generator that we use needs to be replaced eventually. It's getting old. So naturally, the question was asked, well, would we use, should we use, is it even possible to use edge delivery services for doing the Sling websites? And we dismissed it pretty quickly because at that point it was document-based and SharePoint or Google Drive. It wasn't clear if we could do that for an Apache project and what would that mean to have access to these things. And so it all seems a little, tricky. But then later on in the evening, after some beers maybe, somebody actually turned it around and said, well, if Sling is so great, why can't you just use Sling for the Sling website? And well, it's a fair point, right? So it's a use case, and could we use Sling for that? So we took that to the second thing that we typically do after adaptTo, the day afterwards. We often have a Sling hackathon or get together, whatever you want to call it, the day where Sling committers get together and try to work on Sling-related topics in person. And so we brought the question there and discussed it a bit. And yeah, I mean, obviously Sling in its current form and packaging doesn't necessarily lend itself that well for a static rendering case, right? Because it's meant as a server in the underpinnings of something which is long running. But obviously you can do websites. I mean, that's what AEM is banking on, right? So the question was, could we somehow repackage it, make it more usable for such use case where you go and want to take some input, render it out as HTML, and just, static renderer, basically. Right? And well, we combined a couple of the ideas I mentioned together to, in the end, come up with a couple of requirements that we thought we would need. We would need, fast startup time, low memory footprint, package everything together that we can deploy it somewhere in the cloud, either in the Lambda or, in the GitHub Action, whatever. To just basically be able to render static content out quickly, but with a Sling rendering pipeline. And so we left it at that. We started to work on putting these things together. And then luckily, after a while, it also happened that there was some stuff in the edge delivery services which has been made available by now that we thought we could use to actually make it work with edge delivery services too. So the idea for this talk was born. It's basically going to be 3 parts. And first we have Carsten, who's going to talk about what we did to get all of this down to something usable for this use case. Then David and I are going to talk a bit about how we can package that nicely for the cloud and compile it down to native to make it super fast. And then in the end, we tie it together and show you how we can use it in the cloud with the GitHub Action together with edge delivery services. And then, so without further ado, Carsten, take it away.
Thank you. Right. And you might be wondering why we are 3 people here up on stage. And I use a quote from Stefan from this morning. We all aged a little bit, and some parts not in a good way. So we need 3 people. We need someone doing the clicking, someone doing the talking. The other important thing is some people during the day or during the days actually asked about what is the future of Sling? Is there a future? Is there anything be done? You see, I'm dressed in black. I'm not at a funeral of Sling today. It's just a bad coincidence. Now, seriously, we in this talk you will see some of the stuff we did in the last year in Sling. So there is still stuff done. One thing that we did is the minimal Sling, and as Karl already teased, why do you want to do that? Okay, one is having a low memory footprint, a small thing that you can deploy. But also, when I thought about a minimal Sling, this was probably 10, 12 years ago, my idea was basically, at that time I was writing a web blog. You might know these things. People today might use videos on TikTok, but at that time it was a blog. And I thought, okay, I could use Sling for my own blog. And I wanted to have something small, which basically allows me to edit some text files and then publish it as HTML. And for that, you probably want all these things, right? Fast startup, low memory, and whatever. And the other thing is, I should maybe go over here. And the other thing is that I also wanted to lower the barrier for Sling, right? So you have to only learn a few concepts, not the whole thing. So I have to click myself. Okay.
I can click.
Just kidding. So what is the road to that minimal Sling? It was actually a multi-year journey. We started like probably 12 years ago. When we came up with Sling 17 years ago, 2007, 2008, we came up with this nice abstraction of resources, resource provider, resource resolver. Most of you, I hope, are familiar with that. But although we had this nice abstraction, we somehow managed to couple the implementations to JCR, because that's the main storage we use for AM. So one of the tasks was obviously to decouple things from JCR so you could start up Sling without a repository. And that brings already, if you manage that brings already the size way down. Then we also managed to use all kinds of third-party libraries. Even if you are just using one class and one method of a library, we used it, and that increases the size, so we try to trim that down. Apart from bundles, OSGI bundles, we have usually OSGI configurations. We also managed that in order to start up Sling, you needed to first create a bunch of configurations, right? Again, minimal Sling, trying to get up Sling without any configuration needed. And on top of that, we also prepared to be able to run this on a flat class path. You know, OSGI uses class loaders, basically a graph of class loaders. So you can use the same library in different versions in that tree. If you're on a flat class path, it obviously doesn't work. So we need to see that we only have one version of a library and all these things. And with that, I created the Minimal Sling project in the whiteboard. So in the Sling whiteboard where we try out things, so you can go there and look at it. And it's basically using the feature model. There's a base feature with all the OSGI stuff that you need, and then a Sling core feature with just the minimal Sling things that you need. On top of that base thing, I have different deployments. So there's a web version of that, which adds the web console, HTTP processing, and so on. And there's an offline version, which we'll see in a minute. And there are add-ons if you want to use sidely scripting, web console, and all these things. Getting into the use case, what did we do for this presentation? It's basically implementing, surprise, a rendering pipeline. So the idea is basically you start up Sling, it reads markdown files from a directory, converts that to semantic HTML, puts it back into the file system. Nice and easy, and then Sling shuts down again. For that, we implemented two new bundles. Basically, one is the markdown resource decorator, which basically decorates a resource, for example, a resource that reads a file from this file system with additional markdown information. And before that, actually, we needed some resource provider that can read files from the file system, which is pretty simple. Because again, we already have a file system resource provider in Sling, but that has all kinds of dependencies, including JCR, actually. So we had a simpler version here. And with that, I think I get into the demo, I hope. Thank you. Right. You see, that's why we have 3 people here, right? I always forget things and need some help. It's when you get at that age. So the first thing I wanted to show you is actually the minimal Sling as a web application. So I launched it in this thingy here. And I'm not used to a Mac either, so that's the tricky part here. You see me painfully clicking around. Yeah, so in the console, you see it started up. Here we have the Apache Felix web console. And you see these are right now 58 bundles, which is already pretty good. It's small, especially if you count that some of these bundles down here, like more or less 10 of them, are needed for sidely scripting. So if you don't need sidely scripting, 10 less bundles. The same, there are some plugins for the web console in here. So in total, if you just need a minimal Sling for the offline case, it's probably like 45 bundles in total. Just to show you some other things, if I can click correctly. Yeah. I really need someone who helps me. Right. So you see there are just a few configurations. In this case, we needed the configuration down here for the file resource provider, where we basically point to read the markdown files from that directory. And that is configured here. So I can just show you that it really works. First of all, I'm now just reading the markdown file from the file system and download it via the browser. And it's a little bit small. I mean, the markdown by itself doesn't really matter for this demo. It's just the list of releases that we had in Sling until September of this year. And to prove that the whole thing works, we just now render this to semantic HTML. And there you go. Right? That's basically it. Reading the file, reading the markdown, converting it to semantic HTML, and presenting in here. And with that, I conclude my demo. Try to get back to the presentation. And let's see what we can do now with the minimal Sling. And back to Karl.
Thanks. So yeah, as you could see, I mean, the cool thing is we now have a really slim and small base that already does everything that we want to do, right? So that's great. Supports the use case, just perfect. So from here, it typically is the case that, I mean, if you want to deploy that, let's say, somewhere in the Lambda or in some GitHub action, you have a packaging problem, right? I mean, it's nice to deploy into OSGI, but how do you deploy the whole thing? I mean, you always need some solution. I mean, we have the quick start in Sling and AEM, and it's the whole history of OSGI is littered with starters, basically. So it'd be nice if you had something like a Spring Boot-like jar that you could just put someplace and run, right? So that was one goal. And the other was that we wanted to be able to compile it natively to make it quick. And luckily, and I talked about this before at adaptTo, I mean, there's this OSGI Connect spec, which effectively makes that possible. It's a way that you can hook into the module layer and somehow have something that makes outside managed modules available inside of OSGI, just like they would be normal bundles. It can come from the Java class path, it can be from the Java module path, or if you compile down to native with Karl, they can be in a native image. And so we wanted to use that here. For us, there's So the spec only specifies the module connector, which is just an API, and then you need the concrete implementation. And again, I talked about this before too. There is one in Felix, it's called Atomos, and it supports JPMS, but more importantly, it also supports the flat classpaths and the GRA substrate images. So David and I were looking into what we could do there, and I showed already that we can kind of get that to work. There were always some issues with it, but obviously here, since we now have the cool Sling Mini features from Carsten, the goal was to make it work with features too, right? So we created, and it's currently in the whiteboard, an Atomos feature launcher, which just takes a feature and assumes that the bundles are to be found on the class path or in the native image, depending on the use case. And then you can just start up from one fat jar, no extraction needed, very nice, very clean. But you have to still create that jar, right? So we kind of wrote an extension to that one. Which is the config feature launcher or feature launcher config, which does just that. You give it a feature, it automatically creates you a fat jar out of it with everything in the right place, including an Atomos index. I'm not going to go too much into that, but so everything's ready. It also, David will talk about that more. You need some configs for the native image typically. So it helps with generating those and puts them also in the jar file. And last but not least, it does some light bytecode weaving to make the whole thing work. That's part of what typically wasn't working in this scenario. Namely, if you use Connect, the problem is that OSGI gives you in the specification assumptions about class loaders, and it also represents the sources of classes as first-class citizens, right? You can get to bundle objects at runtime, right? So, and you can ask both the class loader and the bundle objects, for example, for resources, and it expects that this identity is respected, right? So if I have two bundles with the same named resource inside of it, well, I expect to get this resource from this bundle and that resource from that bundle. But if I have a flat class path, only one of them can win. Right? So we have an Atomos index, which records what bundles had what resources. So we have that embedded. And then we do some bytecode weaving to basically hook into get class loader and get resource calls to effectively then redirect to the right places, depending on where the call site is coming from. So getting that to work, I know it's complicated. It might not be a big deal for you. It is for me because it really made stuff like the web console, for example, work perfectly, which was never the case before. So with that, we were all set to actually, get it working. And just to prove that point, I hand it over to David.
All right.
It's the next demo.
Karl. So for the next demo, we're going to go back to the command line. I'm going to kill this process here. Now here we're going to show two things at once. First of all, we're going to show the offline Sling capability that Carsten showed in his diagram. So basically starting up Sling, rendering a page from Markdown to HTML and shutting down Sling in a clean way. That combined with the Atomos flat class path approach that Karl just talked about, and to render these pages. Now, the one thing that we're interested here as well is how long does it take, right? Because we want this to be fast. And anyone know how long the quick start takes to start up in AEM? Maybe not fast enough. So let's run this. And it took about 840 milliseconds in Java, so that's not too bad. This has generated, I can quickly show here in this directory, it has generated a HTML file from the input. So it did generation, doesn't really matter what's in it, but it basically did what Carsten showed in the browser there, but then in an offline way. So this is basically the starting point, right? Because one of the key things that the Atomos stuff gives us is the ability to compile this natively and go even faster than this. So let's go back to presentation. Right, so just a few words on native compilation in Java. That is typically done using Graal and the Graal VM. Or as Dutch people would say, graal. And the way it works is you take a bunch of class files and you pass it to the native image compiler and out it spits a binary. Now, that's not the whole story. You have to give this native image compiler some metadata because it compiles stuff out of the class files that were there in the Java, in the normal Java use case, are still there. Like, for example, if you use reflection, that stuff is gone in the native image unless you explicitly tell the native image compiler to retain it. If you want to call getClass.getResource, Karl had that as an example in his slide, you have to tell the native image compiler about it because otherwise it doesn't work. And this is actually a lot of work. This is really a big job, even for something as small as Sling Mini, because it uses libraries that you're not familiar with. And, it's just a lot of information that you potentially have to decide at least on. Now, the good news is that if you're using OSGI, that OSGI already specifies a lot of that information in its metadata that it provided before. If you want to start a bundle, that's done using reflection, but the bundle activator is already declared in the manifest header. So that information is there. If you use a DS component, it's used using reflection. But there's the DS component descriptor, which has all that information in there. So it's really cool. You can just figure it out automatically. So the people at Atomos have written this Atomos Maven plugin that if you have an OCI application described completely in the Maven POM, you can generate most of this automatically. It may not be 100%. You might need a few extra things, which you can then put in the POM as well. So everything is in one place. And with this Atomos Maven plugin, you generate the native image metadata, and everything works nicely. Thank you, Carsten. But in our case, we have our application, our Sling Mini application, described as a feature model. So that's not really everything in a POM. So for that, Karl created the Atomos Feature Launcher config executable, which under the covers reuses a lot of the Atomos Maven plugin, basically uses the same metadata from OSGI to generate the metadata for the native image and compile the Sling Mini that way. So that's a really nice way to go from features to a native binary without having to do too much of the hard work yourself. Maybe one or two little issues to be solved. So for native compilation, it's a really fun thing to try out if you haven't, because it brings Java back to the bare hardware kind of level. You can try out a bunch of optimizations as well to make it faster. In our case, we have just the -03 flag, which is just optimize, tell the compiler to optimize as much as it can. So that's a no-brainer. It just makes the compilation step a bit longer. In our case, because our process is so short-lived, we can disable the garbage collector. Because what garbage is there to collect if you only run a second or so? So we use this epsilon garbage collector, which is basically a no-op garbage collector, switch that one off. Then there is the march equals native flag, which optimizes the binary for the native processor that you're running on. It's an interesting flag that we're using. We found it on my Apple M1 Mac. It doesn't really make so much of a difference. However, if you use an Intel machine, it actually does make a lot of difference. So, that screen just switched off. It goes back. So that's a flag. You should definitely pass it in. And then finally, there's this profile-guided optimization, which is really interesting. And it works like you basically first compile your binary with PGO instrument. Then you run it the way you would run it, which is basically really good in our case because we always run it the same way. And when you're finished running it, it writes out a file, like a profile file, which you then use again when you compile it the second time with just -PGO. And then it uses that profile information to optimize your binary. So we used all of these things. And in the end, we want to figure out how fast can we really make Sling, right? So we're launching Sling, rendering Markdown to HTML, shutting down. As you saw in the previous example, the plain Java case, it's about 900 milliseconds on my Mac. We were quite lucky when the time I ran it. It was about 850, but it's around about that area. It's not always the same, right? Because it depends on what other things your computer is doing. Native compilation without any optimizations got me down to about 134 milliseconds for the Sling Mini offline run. And then basically adding all the optimizations on top of that got me under 100 milliseconds. That's on the Mac. On an Intel machine, we've seen it even lower. We've seen values as good as about 60 milliseconds for an execution of Sling to do this work. So that was really cool. Memory consumption is not too bad either. We've about 50 megabytes. I think there's still things that we can do there, but that's already pretty cool for a Java process. Okay, and with that, I'm going to do a little demo. You can do the demo too, Carsten, if you want.
No.
So just to show you that this is actually real, I may have to run it a couple of times in this bottom left display, because the first time it is usually a bit slower. Just going to run it twice. So you see now it's already at 100 milliseconds clean. Right, so that's not even the fastest. Maybe the next time, well, there we go, 96 milliseconds. It depends a bit what the laptop is doing. But this is really, really fast, right, for running Sling. And a really fast Sling is great for running it as a Lambda, which is what Karsten's going to talk about.
Correct. Right. So Lambda, right, means basically serverless. You can run that stuff in a function or a GitHub action or wherever you want. And let's get a little bit into AEM Edge Delivery Services, because that's what everyone wants to see at this conference. As you know, Edge Delivery Services is pretty good at publishing things very, very quickly. It uses client-side rendering. Your code is stored in a GitHub project, and you have various authoring options. Right, on one hand, document-based authoring. You can use AEM authoring with Crosswalk. And now we have the new option, which is Markdown, because there's something that already Lars announced at or mentioned at the panel, that is Edge Delivery Services supports bring your own markup. So basically all you have to do is create semantic HTML, put it somewhere, and point Edge Delivery Service to that location. You can see the FS step, which is usually the thing that tells you where your content is, so SharePoint, Google Drive, Markdown directory in this case. And yeah, like I said, all you have to do is create this semantic HTML, and as we have shown in the demo so far, with this offline Sling Mini, you can do exactly that based on the Markdown. And with that, back to David.
Okay, thank you, Karsten. Yeah, so what we're going to do is we're going to use Sling Lambda style to render Markdown into pages served by Edge Delivery Services. So for that, I'm going to start by looking at my Edge Delivery Services site that I'm using for this, and I'm going to use it to render the Sling releases pages, that page that Karsten showed earlier as well. And this is just a plain vanilla, Edge Delivery Services site from the boilerplate. I only changed the styling a little bit, the CSS, to make it look like the Sling releases page that is there already. And then the only other change that I made here is the FS tab, which is basically, you can see there as on Karsten's slide, it's telling the Helix admin when I preview where to get the plain HTML from. The plain HTML is the semantic HTML that Karsten showed earlier that is rendered automatically using our Sling offliner. So this is the site, the Edge Delivery site. If I load the page now, I'm just going to make this a little bit smaller. Here, so this is the current state of that page. It looks a bit like the Sling releases page, and this is like it has a September release on it, and so on. Okay, so let's add a release using Markdown and see if we can get the Sling Mini to render that automatically for us on this page. So I'm just first going to do this. Yes. Right. So here's the Markdown. I'm just going to copy, because otherwise I make too many typing mistakes. Right. So here I'm going to add an October release. Right, there it is, October adaptTo release. I'm going to save that and commit it and push it. Right, so I made a change to the Markdown. This is all pretty simple stuff. Now I'm going to go to my other repository which is the Sling Lambda. Now, there. So this one has a GitHub action that kicks in when you do a push. And you can see it just got kicked in for our adaptTo commit that I made there a second ago. If I look at that, it basically, no, just going to collapse it a little bit. Okay, so what it does is it runs the Sling Mini offline that we've been running before in the examples and timing, except here it's running inside the Docker container, so that's the only difference, so that it can easily be run on the GitHub action. Then when it's finished, it uploads the output HTML onto GitHub pages, which is basically where the Helix admin can fetch them from. That's basically that URL that we were showing on the FS tab. And then when that's done, it basically, the last step is to publish it to Helix so that the site is updated. So let me go and see if I can refresh the page and see the new content on the site. And there it is. So basically, we've updated the site just by editing some markdown. And what is otherwise done by the Helix bot is now done by Sling, which I think is pretty cool. And with that, it goes back to Karl for the last part of the presentation.
Yes, which is basically just to say it's done. We have to move some of the components out of the whiteboard if there's enough interest. For the feature launchers. But other than that, the Markdown rendering we have right now doesn't really support Markdown tables in the format that Edge Delivery Services will like it. So there needs to be a little bit of work done there. But then you could actually use it for doing our Sling website visit. So then you just need some help to port the Sling website actually to that approach, and then you can use it. And that's our talk.
And that's it. Any questions?
So how was it? Like one is clicking, the other one is talking, and the third one is demo. Who's answering the questions?
You.
Yeah, people are asking themselves, is this Markdown to HTML rendering, is it the one used in Edge Delivery Services by default?
No. This is what we did. That's why I said we have to, for example, extend it if you wanted to render the tables, and so it's not exactly the same. But the interesting aspect is, and I'm not sure how familiar people are with this, right? But the nice thing is, it really uses a Sling rendering pipeline. So and this approach to come from a source that's decorated to the actual HTML. So if you wanted to support something else, you could just write an adapter that does that to, for example, support other file formats.
Yeah. If you want ASCII doc instead, it's just as easy.
It's easy to do.
In which practical situation would you recommend using Sling on the edge?
Always.
Ah, that's a good answer.
Well, I think during the panel there was actually part of that was discussed. That was the reason why there is a bring your own markup support in the first place, right? Sometimes you have situations where that makes the most sense for you, either because of that's how you like to author it. You could, in our case, have different other formats which you want to support, which are not supported by Edge Delivery Services. Or in this case, as I said, the main motivation here was I don't see how we could use that in an Apache setting, right? SharePoint or Google Drive, and then how do the committer? I'm not sure if we could make that fly. It's possible, but so it's a different.
I mean, the other case is basically if you already have a lot of Java code that would fit into this model, deploying it into a function, then I think it makes sense, right? So you can just use a Sling Mini, add your own bundles on top, and run it wherever you want.
And just to add, I think yesterday there was a question whether Edge Delivery Services supported Markdown as a content format, right? And this is exactly what we were demoing today. So there seem to be people who want something like this. And yeah, you can use Sling for that.
Excellent, yeah. Did you ever consider rewriting Sling core bundles to use container first, natively compiling frameworks like, for example, Quarkus?
No.
So, and we hand up not with a question, it's just like a general observation from the audience. Seems like a hell of a lot of work just to convert Markdown to HTML.
But it was fun. So
Yeah,
why
exactly.
not do
That
it?
was like that, but it was fun. Absolutely. It was great having you all on stage.
Thank you.
Thank you.